everybody. Welcome. Today, together with my colleague Harry, we will present you a story around the solution that we built for one of our customers. The customer is Peifer and Langen, and we will be talking about usage of different advanced technologies to transform traditional manufacturing into the data-driven ones. Maybe just a little introduction about myself, and Harry, if you could also talk a little bit more about yourself. Zoriana Doshna, Head of Advanced Technology Productization at SoftServe, as well, driving our generative AI lab. And Harry?
Yep, I'm Harry Graywell. I lead cloud as well as strategic SI partnerships at Litmus.
Alrighty, so as I mentioned already, we started working with Peifer and Langen a while ago. We are one of their strategic partners, and together with Litmus, we delivered one of the solutions for them, which helps to transform their manufacturing business into data-driven. Plus, we also enabled cropped yield optimization based on advanced technologies. Why SoftServe a little bit? SoftServe is a global organization which was founded more than 30 years ago in Ukraine, out of university and two professors, and now it's grown to more than 9,000 employees across different countries. We do have 46 offices and delivering really services across different industries. We cover end-to-end custom software development and consulting for our clients. We do have product management and analytics office. We do have different types of software development. Plus, we work a lot with advanced technologies. AI, ML, big data, robotics, IoT, and everything around that, building end-to-end solutions for our clients. And we're not doing that alone, but we also do it with our customers and partners, like Litmus, for example. A little bit about the customer story. As I mentioned already, they are pretty long players on the market. They are producing sugar out of the beetroots, and they had their production facilities still set in that old-fashioned environment, but we together took a challenge a couple of years back to transform that, to implement digital transformation based on technologies and make decision-making for them data-driven. Some challenges that our client had at the very beginning were related to their manufacturing processes. Obviously, there were a lot of people still doing work manually. If you need to control some of the machines or you need to make a decision, you still have to come and adjust it manually. What if that could be done in automated way, right? Second, aging population, which is one of the most important and known challenges right now in manufacturing, when the tribal knowledge is not kept, but it is gone together with the employees, was one of the challenges that we also tried to address. Lack of storage of the information or the data about the production processes and some of the parameters in one place. This is something also that we have helped our clients to solve with advanced technologies. Together with Litmus, we designed a solution that helped us to automate the control of different types of the machines at the processes. We utilized robotic operating system version 2, plus Litmus devices and cloud technologies to build that hybrid architecture to enable our client to collect the data, analyze some patterns, and then build dashboards with some actionable analytics for their employees. Yep, maybe Harry, you can speak a little bit more about why Litmus.
Yeah, certainly. Litmus, essentially just to kind of give you everybody an intro what Litmus is an edge compute platform specifically built for the manufacturing industry. The reason why Litmus exists is because of this gap between IT and OT data. We know on the OT side there's a lot of complexities with PLCs, systems over time that have grown, but what that has created is a lot of challenge with data silos, data consistency, also the access to that information. So what Litmus does is Litmus bridges that gap by connecting to sources directly. Litmus's IP is built on connecting to industrial data sources natively. So we connect to PLCs, message brokers, OPC, UA servers natively within a plant floor. Once we have access to that information, we normalize that data. Plus, we also allow you to build native data models at the edge. And this is all happening at a plant floor before the data ever shows up in a data lake or a database. This is all happening in stream. Once you define your data models, now you have the capability to execute local workflows. So if you're trying to calculate KPIs locally, like Peifer and Langen wanted to do, you could do that locally and give access to that information to local systems like MES systems or SCADA systems that need access to that information. And once you have built that rich data model at the edge, it gives you now the capability to create a standardized model across your enterprise, across plants. And now this data can then be sent to different cloud systems, different databases. And this also lays a foundation for your data to exist in the cloud to power some of these AI, ML use cases that are being sold all over the place, because you need consistent, solid data before you can even have an AI strategy built on top of that. The reason why we started working with SoftServe is because they're one of the few systems integrators out there that are versed with OT infrastructure, also on the cloud side. So it created a good synergy for us to work with SoftServe and Peifer and Langen to create a hybrid edge to cloud infrastructure that allows Peifer and Langen to scale. Now with systems, it's never really been a problem of solutions and creating data sets. The problem has always been scale. What Litmus does really great is we have an edge management capability that allows you to replicate solutions from one plant to the other and allows customers to scale solutions. There's tons of solutions out there that allow you to execute or build use cases, and that are great for plant number 1, plant number 2, but they're too expensive to expand. So that's the challenge we eliminate together with SoftServe and our expertise together. One of the use cases in conjunction with the industry use case that we did was with the agricultural robot. So Peifer and Langen, being an agricultural dependent customer growing sugar beets and processing them, they had a lot of challenges in their field where they wanted to, let's say, laser zap all the different weeds in the field. So what they did was, on that robot, they deployed Litmus Edge on a small gateway PC to collect that data. Essentially with the goal of collecting this data out in the field, offline first. So once that data is available, they can make local decisions on that Litmus Edge platform if they need to, store that information, and as that information gets normalized and transitioned, it is also stored locally, offline first storage. And then the challenge was, how do we scale that? So with the Litmus Edge management capabilities, we can scale that to hundreds of robots at the same time because we're replicating that solution across the board. Secondly, from a solution perspective, I'll give that back to Zoriana to explain at a high level what that solution looked like for all of us.
Yep, like Tim here, the basic concept of how the solution worked. Just imagine Peifer and Langen is growing the sugar beets at the specific land for small period of time, I would say, during the year, right? And what they have to do, they have to make sure that out of the land that they are using, they are getting maximum yield, right? In order to monitor each and every plant and to make sure that the plant is growing healthy and there are no, like insects or anything else that is damaging the beetroots, they decided to use robots to navigate through different rows with the yield and then monitor the status of each and every one. So once the robot is sent to a field, as Harry mentioned, it is collecting the data. The data is stored exactly on the robot, and once it's coming to a dock station, everything goes up to a cloud. After that, the data is aggregated into dashboards for conditional monitoring, some alerting, to then back to the field teams to take a decision what has to be done with the specific crop or with a specific part of the land where the beetroots are rising. So this is the generic model of a solution that we implemented using Litmus as a technology enabler and AWS Cloud as data storage processing and analytics building as well. Yep, some of the outcomes that this solution delivered to our client. First, its visibility, how the crop is looking right now and what is the predicted yield that we could take, right? In that case, improved crop yield overall is one of the benefits that customer received when he was able to use the data from the fields almost in real time to understand the situation and predict. Then the second one is cost and time saving. If you can detect that there is something wrong right now with the specific area of the land, with the specific beet root, you can make a decision in order to avoid, like transmissioning of the insects or whatever to different other parts of the land and the crop. So you can protect your yield and thus optimize the costs, because you will not lose that, but you will still be using that yield to produce the sugar. And then enhanced decision making. The customer, having the data which is collected in real time, was able to have this data-driven decision making provided to those teams that are monitoring the state of the fields and making the decisions what to do with the specific yield.
And just to recap the whole premise of this presentation, essentially is to kind of highlight the power of what Edge and Cloud can bring together. This use case particularly is a great example of a hybrid Edge to Cloud data ops scenario, where a lot of data ops are happening locally on either assets that are distributed like the robots, or even on a factory floor where you can build different types of data pipelines that enables you to now create a localized data infrastructure, combine that with cloud infrastructure, and create a true edge to cloud infrastructure that is manageable and scalable, not both at the cloud and at the edge. So with that, we're going to transition over to questions and see if there's any curious questions out there. No questions. Well, that's always awesome. You must have done a great job then.
Test. Hi, quick question. Is that linked into the SAP solution to trigger when the field operations actually have to go and fix the watering? Or how does that actually transfer into more of an ERP scenario?
Yeah, I think that right now, at least at that part of the solution, that was customly built dashboard that is now being used by the field teams, and the communication between the control center, let's call it like that, and the field team to make a decision around the specific field. So it was not integrated in this case with SAP or any other system.
Essentially, because a lot of the compute, a lot of the analysis is happening at the edge level, but the data certainly makes it to a certain endpoint. So I think that's the next phase of their journey is how do you translate that to action at an enterprise level? Because they certainly have that field monitoring built in that is being translated to field teams, and then these decisions are made at the field level, which are translated back to efficiencies on the field. Yeah. Awesome. Any other questions? If not, then we can wrap it up early. Oh, there's one question back there.
I do have a question, and that is concerning the business or the information flow. So you showed that you actually transfer the entire data up to the cloud once you actually reach the docking station. Now I see there is a lot of information, which is very specific to the local condition. For instance, the moisture or the humidity of the soil, stuff like that. That is, I measure the humidity level. I actually see if I need to water something locally. But how much of that information, when it comes up to the cloud, is used to make general, system-wide decisions? So.
Yeah, I think that in this specific case, we had custom sensors put onto the robot, and you can add additional ones to also retrieve information which is required. Plus, you can also have some integrations, let's say, with weather forecasting, and you can use that data also to make some decisions. And if I'm not mistaken, the robot is sent to a field once per day, so the data is collected almost every evening to make some decisions around the crop yield overall.
Yeah. Well, if there's no more questions, we can wrap this up. Thank you, everybody, for your time. We appreciate it.